Hello guys, so today I will start with an important chapter, the solid state. Now start with an intro. In this chapter we do study of solids. Mostly we are surrounded by the solids and also we use for our different purposes. And its property depends upon nature of its particle and particle binding force. As liquid and gases are also called fluids due to their ability of flow. Now let's go through classification of solids. So first point is shape. In crystal solids you get regular shape in molecular level but not in the amorphous. Melting point graph of crystalline solids is also too sharp as compared with amorphous. Means if we melt some crystalline thing or solid, so after a certain temperature it will melt, but for amorphous it melt like wax slowly. Crystalline solids are anisotropic, mean some physical property like resistance and refractive index give different value from different directions, but in the amorphous side we are not able to study such changes, so we put in the isotropic region for amorphous. The last change, crystalline solids have long range order, mean same order of molecule is repeated in the whole crystal, but in the amorphous it has short range order. True solid is also a name of crystalline solid, and for amorphous we will say that pseudo solid or super cool liquid. Now last examples of there. For crystalline solids, quartz and NaCl, lot of more you can find in your NCERT book or web. And for amorphous solid is quartz glass. Now we will classify the crystalline solid. So in this we have four types. First is molecular solid, second ionic solid, third one is metallic solid, and fourth is covalent solid. So first we will go through molecular solid. In this, their constituent particles are molecules, and it has three types more. So first is non-polar, polar, and hydrogen bonding. So in the polar, the bonding force is London or dispersion force, and you can see example in the table that is like argon or carbon tetrachloride. Polar have dipole-dipole interaction, and example is HCl. And last one is hydrogen bonding. In this, their constituent particles are binded by the hydrogen bond. And so second type of crystalline solid is ionic solid. Its constituent particle is ions and it is combined due to Coulombic force. An example are NaCl or magnesium oxide. Last is metallic solid. They are formed or means their constituent particles are positive and negative ions and they have metallic bonding. Examples are iron, copper, and many more. Covalent or network solids are formed by the atoms and they have binded by the covalent force. And examples are silicon carbide, silicon dioxide, which is quartz, and carbon diamond form. I also mentioned some more property, but that is not too much important, but just go through. Crystal lattice. When we plot all the points of any crystal in 3D space, so formed lattice is called crystal lattice. As you can see in the figure, we plotted all the points and we got this crystal lattice. And then the smallest part of the lattice, which is repeated again and again to form this complete lattice, is called unit cell. As you can see, here we have unit cell which is repeated again and again to form the whole crystal lattice. Now we will talk about a French mathematician, Brevis, who explained 14 different possible 3D lattice and put name as a Brevis Lattice. So before defining it, they gave some which are as follows. Each point is called lattice point or lattice side. Second is each point is represented by constituent particle. And third one is lattice point joined by the straight line, not the curvy or curvature. So for explaining this all, Brevis used 6 parameters and 3 are edges A, B, C and 3 are the angles between them alpha, beta, gamma. Now we will study about classification of unit cell. So in this we have two types, primitive type unit cell and centered unit cell. So in the primitive unit cell, the constituent particles are present only at the all corners. But in the centered unit cell, the constituent particles are present at the corner, plus it also present inside or anywhere else in the unit cell also. So centered unit cell also have three types: body centered unit cell, face centered unit cell and end centered unit cell. For the body centered unit cell, we can say in short form this is BCC. For face centered, FCC, and there is no short form for end centered. So now we will go through body centered unit cell. In this, particles are present at all the corners as well as at the center of the body center. Face centered unit cell, it has also little bit some differences also there, means constituent particles are present at all the corner and also in the center of each faces. And last is, in this particles are at the corners and also at the center of any two opposite faces. Thank you for watching our video. So please like and subscribe for more content. Thank you.